Hi, welcome back to my channel. My name is Gina. In this video, we're going to talk about the implicit differentiation. Implicit differentiation is a more advanced technique to find the derivative. For example, you want to find the derivative of y, which is a function of x, but you don't explicitly know the function f of x. For example, if y equals to x squared, then we simply need to use the power rule to find that the derivative of y is 2x. However, if the equation is y squared equals to x, then this equation tells us that y implicitly defines two functions. The first one is square root of x, and y also implicitly defines another function, which is negative square root of x. Square root of x also equals to x to the power of half. Then we can use the power rule to find that the derivative of y is half times x to the power of negative half, which also equals to 1 over 2x to the power of half. And since y equals to x to the power of half, so we can substitute the x to the power of half by y. Now let's look at the other function, which also equals to negative x to the power of half. Then we can use the power rule to find that y prime equals to negative half times x to the power of negative half, which also equals to 1 over 2 times negative x to the power of half. And since y equals to negative x to the power of half, so here we can substitute this by y, so this also equals to 1 over 2y. So we found that the equation y squared equals to x, we can find its derivative y prime, which equals to 1 over 2y. However, it is not always that simple to find y equals to f of x. Sometimes f of x may be really hard to solve. So when an equation implicitly defines a function or more, then we can use the technique implicit differentiation to find the derivative of y. Now let's take the same example, y squared equals to x, but we're going to use the implicit differentiation to find y prime. So first we assume that y is a function of x. And the trick here is we're going to take the derivative on both sides with respect to x. So the left-hand side is d over dx, which means the derivative of y squared equals to the derivative of the right-hand side. Since we know y is a function of x, so we can use the chain rule version of the power rule. So the left-hand side equals to 2y, and the chain rule says we need to times the derivative of the inside function. So we have to times y prime equals the derivative of x, which is 1. Now we can isolate for y prime. So y prime equals to 1 over 2y, which is the same answer as before. So that is your final answer. Derivative of y for the equation y squared equals to x is 1 over 2y. Now let's look at a more complicated example. In the last example, we can actually find the function f of x. We can solve for y, which equals to positive and negative of square root of x. However, sometimes it is hard to find the function. For example, here I have an equation that involves x and y. 2x squared plus xy plus y squared equals x plus 3. It is possible to solve for y using the quadratic equation. I can rewrite this equation as y squared plus x times y plus 2x squared minus x minus 3 equals to 0. It is possible to solve for y using the quadratic equation. Now the a is 1, b is x, and c is 2x squared minus x minus 3. But after we find the function for y, it will be hard to find the derivative because you'll need to use the general version of power rule, the quotient rule, and the product rule. So when you see an equation that involves x and y, then you can assume y is a function of x and use the implicit differentiation. So the first step is to take the derivative on both sides. So the left-hand side would be d over dx of 2x squared plus x times y plus y squared equals to the derivative of the right-hand side, which is d over dx of x plus 3. Now the derivative of left-hand side. First term is 2x squared. Using the power rule, the first term is 4x. Plus, the second term we have x times a function of x, since we assume that y is a function of x. So here we have to use the product rule and the chain rule when we take the derivative of y. So the product rule says derivative of x times y is derivative of x times y plus x times derivative of y, which is 1 times y prime, since we have to use the chain rule whenever we have a derivative of y. Now the third term, derivative of y squared. Using the chain rule version of the power rule, it is 2y times y prime. And it equals to the derivative of x plus 3, which is 1. So now let's isolate for y prime. So the third and the fourth terms have y prime. So I will write this on the left-hand side and move the first and the second term to the left-hand side. So x times y prime plus 2 times y prime equals to 1 minus 4x minus y. Now I want to isolate for y prime, so I'll factor out the y prime. So x plus 2y times y prime equals to the right-hand side, 1 minus 4x minus y. So now I get the derivative of y, which is 1 minus 4x minus y over x plus 2y. So that's the end of the video. I hope this video helps you. If you have any questions, feel free to comment below, and I'll see you in the next video.